Hello guys, welcome to this new video. In this video, we are going to see about bush-to-pin flange coupling. A bush-to-pin flange coupling is a mechanical device used to connect two shafts, allowing for torque transmission while accommodating some misalignment. The major components of bush-to-pin flange coupling are the flange. The coupling typically connects two flanges, each attached to a shaft. The next is bushing. A bush is used to provide connection between the flange and a pin. It often acts as a flexible element, allowing for some movement and misalignment. The third one is pin. The pin connects two shafts or two flanges through the bushings, transmitting torque while providing a degree of flexibility. The major advantages of bush-to-pin flange coupling are alignment tolerance, ease of maintenance, and durability. When it comes to an alignment tolerance, can accommodate misalignment between the shafts. And ease of maintenance, pins can be often replaced without disassembling the entire coupling. The durability, designed to handle high torque loads. The major applications of bush-to-pin flange coupling are commonly used in industries such as manufacturing, mining, construction, where robust coupling solutions are required. The installation and maintenance. Ensure proper alignment during installation to minimize the wear, and regular inspection for the wear on pins and bushings can prolong services life. So these are the basic brief about bush-to-pin flange coupling. Next, we are going to see how to create a CAD model for each and every component in the bush-to-pin flange coupling, and also we are going to see how to create an assembly along with animation for that. So let's get into the CAD work. So in CAD work, I'm going to use Creo parametric to develop this bush-to-pin flange coupling. Here I can able to show two different drawing sheets in the CAD model where I can able to represent the 3D of bush-to-pin and 2D of bush-to-pin flange coupling. So in sheet 1, I'm going to represent the 3D representation of bush-to-pin flange coupling with all the required dimensions has been mentioned here. Along with there is a dimensions for pin as well. In sheet 2, I'm going to represent the 2D representation of bush-to-pin flange coupling along with its side view. So based on the help of these two sheets of the drawing, we are going to create a CAD model for bush-to-pin flange coupling. There is two assumptions I'm going to take over for this CAD model. The first assumption is the diameter of the shaft, which is I'm going to assume as 30 mm. So this diameter is the value which is going to replicate for all other dimensions in the bush-to-pin flange coupling and going to create the CAD model. The second assumption that I'm going to take care is I'm going to use first angle projection for this CAD model. So let's get into the 3D work. I'm going to create a new file and I'm going to give name as male flange. Male flange is the part which is in the left hand side of the bush-to-pin flange coupling, which I'm going to create right now. So I'll just enable the planes. To get into the CAD model, first I'm going to use a revolve command to revolve the flange profile. So I'm selecting the revolve command, I click on the define and I'm selecting the front plane as a references and I click on sketch. So now you can able to see the sketch workbench has been activated to create the CAD model. I click on the sketch view, so it will be convenient to create the model. I disable all these things. I'm going to use axis line in the horizontal and center line in the vertical, which is going to replicate the revolve command for the flange. So before getting into the dimensions, I'm just going to create a basic sketch of this. So this is the basic simple sketch of the male flange which is in the left hand side of bush-to-pin flange coupling, and I'm now going to remodify all the dimensions as per the values which is required for us. First, let me align all these dimensions in an order. Here, this is the minimal internal dia where there will be a hole in the bush-to-pin flange coupling and the shaft to be provided in this area. This diameter is always equals to the shaft diameter, which I'm considering as 30 mm. So now based on this dimension, I'm going to remodify all other dimensions as per this drawing. I'm considering this height as 0.85 into D. So now I'm going to remodify all the dimensions. This dimension is in diametric value as of now. I'm just going to remodify to the radial. The radial distance of this value is equals to 0.85 into D. The total height of this flange in radial is equals to 4.5 into D divided by 2. First let me get it this in the 4.5 into D, then I'll make it as divided by 2. The distance from the top surface to this edge is equals to D value. Next, I'm going to modify the horizontal dimensions. The total length of this flange is equals to some value, let it. Next, I'm going to modify the horizontal dimensions. The distance from this edge to the first surface is equals to 0.5 into D. The next value from this line to this outer surface is equals to 0.3 into D. And the distance from this outer surface to this edge is equals to 0.7 into D. Now the only dimension pending is this particular diameter. The value from here to this line is equals to D, which is I'm going to replicate. Now I'm going to add a fillet in this sharp corner to avoid the sharp edges. So I'm going to select the arc and I'm selecting these two lines and I'm just going to make tangent to it and also tangent to the horizontal lines. And I'm going to remove all the unwanted lines in this. So here we can able to see the diameter of the internal hole is equals to the shaft diameter, which is D. The total distance is equals to 1.5 into D, or else we can make it as from here to this distance will be like, sorry, here to this distance will be like 15, which is equals to 0.5 into D. The remaining distance is 0.7 into D and the total distance is 1.5 into D. So the height from this radial to this line is equals to 0.85 into D. The distance from the top surface to this line is equals to D, and the total height of this flange or the total diameter of the flange would be considered as diametrically 4.5 into D. I'm considering 2.25 into D as a radial one. Now I just click OK and I can able to see the flange has been created as per the dimensions which we have given. The next value, we are going to have 4 holes in this surface. To create holes, I'm just going to select the hole command. I select the surface, and to give the alignment to the hole, position to the hole, I'm just going to use these two lines. One line I'm going to fit with the horizontal plane and the second line I'm going to fit with the vertical plane. In vertical plane, the distance will be equals to 0 since we need it in the center point, and in horizontal the value is equals to 1.75 into D, which is called as a PCR. PCR is a form stands at a pitch circle radius. If it is in the diametric value, it will be considered as PCD. pitch circle diameter. Since I'm going to take it in a PCR, it is called as a pitch circle diameter. It is defined as the distance of the center of the hole to the center of the axis of the entire object. The diameter of the hole is equals to 0.85 into d. I'll just consider it as 20 mm and I click OK. The depth of the hole is, I'm going to take it as through all, so the hole will be generated until all the surfaces, and I click OK. So this hole has been generated. Now I'm just going to pattern this hole to all four directions in the radial way. So I select the hole command, click on the pattern, drop down here, click on the axis, and I just need to select the axis in the middle portion. Now we are going to select the number of members in the first direction. As we know, we required 4, it is already there, and the angle between each hole should be as 90 degree. So 4 9s are 36, it will covers all 0 to 360 degree. I'll just click OK. So 4 holes has been created. This is the simple CAD model structure for male flange. Now I'm just going to add some fillet on the all sharp corners where we don't require 2 sharp corners in order to avoid some accidents. So the radius of this I'm just going to give as 3 mm, which is 0.1 into d. And the area where the shaft is getting inserted, the particular area, I'm going to have a chamfer in the transition of 45 into 3. I'm going to select the method as 45 into d, where the d value will be considered as 3. So the chamfer value will be considered as 45 into d, and the flange has been created. So this is the simple construction of the male flange which I created. So next I'm going to add a color for this flange. I would like to give yellow golden for this. One thing I just wanted to add on here is there should not be any fillet radius in this internal edge where the male flange is going to get connect with the female flange. In case if there is a fillet and there will be a gap will be created, and it will be leads to some power loss. So all the times this sharp edges should be as a sharp. We can have a very minimal radius, but it is recommended to be as a sharp to avoid the power loss. So this is the CAD structure of male flange. I would like to modify this diameter as 18, which will be even, or of 15, which will be even more good. Yeah. So this is the concept of creating male flange. Next we are going to create the opposite flange, which is female flange. I would like to save this model, and I'll just click on new command, and I'm going to click female flange. So in female flange, as same as male flange, we are going to use a revolve command. I'll just click on the revolve command, and I'm selecting the front face. Click on the sketch view. I'm going to give axis in the horizontal and center line in the vertical. And I'm going to create a CAD structure for this female flange in a very simple way. Later we are going to modify these dimensions as required as for us. So as we discussed earlier, for the male flange, the internal minimal diameter of the hole will be always equals to the shaft diameter, so that I'm going to take it as directly value as d. The height of the flange from the radial to here is 0.85 into d, and the total height is considered as 4.5 into d. In the diametrical, I'm going to consider in the radial value, so it will be considered as 2.25, sorry, 0.25 into d. The next, I'm going to modify the horizontal dimensions. The distance between the height of here to here is equals to 5 mm, which is not related to the diametrical value. It is always equals to the value of 5. The distance from this line to here is 0.85 into d. The gap between this line to this line is equals to 0.5 into d, and the distance of this total length is equals to 1.5 into d. So this is the basic structure of the CAD model of female flange. Let me correct these dimensions to be in an aligned position. So this is the basic CAD structure or sketch view of this female flange. Now I'm just going to click OK. So the female flange will be generated in terms of it. In the same way, we are going to have a radius for all these sharp corners as 0.3, and also I'm going to have a chamfer at this edge as a 45 into 30. Now we are going to add holes on the surfaces, which is same as it is like a previous one. I'm going to give dimensions to this vertical plane as well as horizontal plane. The pitch circle radius is equals to 1.75 into d, and the vertical horizontal distance will be equals to 0. The diameter of this hole here we are going to give as a minimal number than the hole which we given in the male flange. That we have given for the value of the value of 15 mm. Here we are going to have it as like 0.3 into d. It is 9 mm. So this particular hole has been generated, and also we are going to give pattern for this. Selecting this hole, click on the pattern command and drop down it, select the axis, select this axis, and it is be default taken as 4 numbers with the angle difference of 90 degree. So you can just click on OK. So the holes has been created. So I'm going to remodify this color with this gray, or else some other color would be like as a blue, like green, red, or brown. I would like to use this yellow. So the male flange and female flange will have a minimal differences between those colors. So as we have created the male flange and female flange, next we are going to create the pin. To create a pin, I'm going to create a new file. I'm going to enter it as pin and I click OK. A new CAD file has been created. Here for pin also I'm going to use as revolve command. So I just click on OK. I'm click on revolve command. I'm selecting the front plane and I'm moving to the sketch view and selecting the axis here and a center line in vertical. So I'll just disable all this. I'm going to create a simple sketch of this pin. The diametrical value of this pin and the dimensions of horizontal dimensions of the pins are going to be modified. So the length of this should be as considering as 5 mm. This length is considered as 0.8 into d, and this length is also considering as 0.8 into d. The diametrical value of this is considering as 0.3 into d, and this value is considering as 15, which we have given in the hole size there. Sorry, this value I'm going to consider as 15. And I'll just click OK. So here this is the structure of the pin which we are going to use in this CAD model. I like to give a very minimal radius just to avoid the sharp corners in this area. So the radius will be considered as 0.3, which will be as 0.01 of the d. For the pin I would like to give a color for red. or else I would like to give a steel color which will be even more bright, and I'll just save this model. And I'll just save this model. So next I'm going to create a bush. For a bush to get a new CAD file, I'm going to create this. So next I'm going to create a bush. To create a bush, I'm going to create a new CAD file and name it as bush. Just click OK. For bush also, I'm going to use revolve command. Click on the revolve, select different plane and moving to the sketch view. Here we are already aware about the diameters of the pin which we have created right away. To create, so we can directly enable the bushes on its own dimensions. So the diameter, internal diameter of the bush will be always equals to the 15 mm which we have created the hole as well as the pin in this area. And the length will be considered as 0.8 into D. I would like to modify some dimensions. This as a 10 mm and this would be as a 15 mm. And I'll just click OK. So bush has been created here and I would like to give a color for black since this bush material is going to be considered as the rubber. So to identify it as a rubber, I'm going to give us a color as black, which is could be as a dark one. Yeah, this is looks fine. As the same way, I'm going to modify a dimension in the pin. That is, this particular diameter is not equals to 15. This should be is equals to 12, which is the outer diameter of the pin will be equals to the inner diameter of the bushes. Okay, this I'm going to have modify as 12. Okay, I'll just remodify it and I will save this. Click on fit in all, click on standard orientation, regenerate and save. So bush is also saved, pin is also saved. The final part which we are going to create now is the shaft and the key. So I'm going to create a part as a shaft. So click on the new file, enter the value as shaft. And for shaft also I'm going to use revolve, or else you can use it as extrude as well. In this I will try to use extrude. Look on the sketch view. Just I'm going to create one single circle with the center line on both the sides. And I'm going to select a center circle with a diameter of 30 mm. And the length of the shaft I'm going to use it as 100 mm, which will be well sufficient to showcase in the model. Now I'm going to create a keyhole. To select the keyhole, I'm going to select the face of the surface and I'm going to create a center rectangle on this edge. The keyhole size width is I'm going to consider as 5 mm and the height I'm going to consider as 2 mm. So sorry, 4 mm. So when we are considering 4 as the height, it should be from the top to bottom, not from the center point to here. So the distance which you will get it in be the standard one. I just click OK and I'll flip the direction and click on the remove material. So the material will be removed, and the length of the keyhole I'm going to modify it for the 45 mm, which will be a sufficient value, or else we can consider as 30, which is equals to D value. That is much sufficient. I'd like to save the shaft and I'm going to change the color of this. The shaft color I would like to give in the brass yam, or else we'll move it as aluminum. This is a reference color, I hope. Yeah, this is a material color for aluminum. Just select this and click OK. We'll consider it as an aluminum shaft. Even there is some basic materials we'll see in the later. Next I'm going to create a keyhole. for key, for key I'm going to create a new part. Click on the extrude, select the front view, and create a center line on both horizontal and vertical directions. As we saw, the width and thickness of the key, width is always equals to 5 and thickness is always equals to 4, and the length of the key has been mentioned in this value is I'm going to consider it as the in shaft it is 30 mm. In flange I would like to add it for another 10 mm, so I would like to consider the length of the key as 40 mm. For key I would like to give in the brown color. Oops, this is kind of a wood to give this one. Yeah. So next I'm going to back to male flange. Here I'm going to make a small modification. The modification in the face to add a keyhole. So I'm going to click extrude on this, switch to the face. I'm going to select this point and I'm going to have a keyhole value. It will be as a 5, this will be as a 4. Sorry, and I'll just click OK. On the direction I'm going to flip on the remove material, the distance will be considered as 10. So here you can able to see the keyhole which has been slotted here. Even for the clearance we can use the length as 12.5, which will be even more sufficient when we are going to proceed in the applications. So the last one is I'm going to add it in the male flange as well. For the male flange also I'm going to click on extrude, selecting this face, switching to the sketch view, select a center rectangle, have a center rectangle, the distance will be as 5, and I'm going to delete this perpendicularity so that I will get this vertical value will be as 4, and the value of cutout will be equals to 12.5 mm on the reverse direction with remove material, and I'll just click OK. So here also we have slotted the keyhole. This looks nice, and we'll save this model. Next I'll show one by one. I'll disable all the planes and axis lines, make it in the standard orientation, and I'll like to rotate this component. This is the structure of the male flange. The next we are going to see is the female flange, the structure of the female flange, and the third one is I'd like to add it for the pin. Pin is the standard part for this bush to pin flange coupling. The next is bush. Since it is a rubber material, the bend I just shown here, which will be get compressed when it is in the applications level. The next way I'm going to use it as a shaft, and the last part is a key we are going to use to connect the shaft and the flanges together. So I hope you guys are aware about how to create the CAD models for each and every part in the bush dip and flange coupling. Now we are going to start how to creating an assembly for this. So to create an assembly, I just click on the new file, select the assembly file, and I'm going to click give a name like bush pin flange assembly, and I click OK. So an assembly file has been created, and all the parts are also has been already opened, and it is in the in session. So you don't want to go to search the parts from your local drive. You can directly get it from the in sessions. So I'm going to first assemble the male flange. I click on the assemble, and I'm going to select, even in the in session you can able to get all these things. I'm going to select the male flange. For the male flange, current constraint it is in automatic, that I'm going to make it as default. So whenever you're going to give default, the origin axis of this particular part and the origin axis of the assembly will be get coincidence in 0, 0, 0. So this is the first part which we are going to assemble here. The next one is going to assemble the female flange. I just double click on the female flange. Here we got the part. So the concept of connecting these two flanges is I'm going to connect this surface to this surface will be as in a coincidence, and we have still 3 degrees of freedom which we need to arrest. The another degree of freedom is in the vertical direction. So to constrain that, I'm going to select this particular surface and this surface to be as a constraint. Yeah, it is also constraint. So here since it is a rotating component in 2 degrees of freedom arresting itself, we can able to ensure the part has been completely constrained. But since we need to have a very good constraint, you can go for new constraint. Once again, it will highlight what is the remaining degree of freedom which is in open. So this is the only remaining degree of freedom which is in open. To constrain this also, I can able to select the particular hole to this hole to be in a concentric or oriented condition. So now you can able to see, even if you click on a new constraint, there will be a 0 degree of freedom, which is all the degrees of freedoms has been completely arrested for this female flange. This is how you need to ensure that the assembly has been completely constrained. So this will be considered as a male flange, this is as a female flange. So next I'm going to add a shaft. I'm selecting this shaft. To add this shaft, I'm going to select this shaft surface to here. So 2 degrees of freedom has been arrested, remaining 2 degrees of freedoms are in left out. One is this movement and the another one is this movement. Now I'm going to arrest the rotation movement. I'm going to click on new constraint, this surface to be get coincidence with this side surface, or it could be as a parallel, yeah, because I have selected this and this. Or else I will delete this. I would like to add this particular bottom surface to this bottom surface, will be considering as a coincidence. Yes. So another constraint which was left is this horizontal movement. The shaft is moving in horizontal direction, so that I'm going to constrain by click on the new constraint. I'm selecting this surface and I'm going to select this surface. This should not be in the coincidence level. I want it to be as a distance, since we are going to insert this shaft somewhere inside this. I would like to add it to the 20 mm and I click OK. Even if you click on new constraint, it will show the shaft has been completely constrained in all degrees of freedom. So this is not required. You can have these 3 constraints and click OK. The same way, the shaft, another shaft is going to get assembled in the opposite direction. I will just repeat it in the same way. So I'm selecting this face to this face, will be getting a coincidence, and I would like to make this face to this face to be as a flipped in with the distance of 20 mm, and the surface of keyhole needs to be get coincidence. So now you can able to see this shaft is also completely coincidenced. Yeah. So just to verify if this assembly is being a completely constrained, or like it is perfectly constrained, we can able to go to view, click on the sections, and you can able to select any of the plane where you can able to section the view. If you section this view and if you click on this particular view, you can able to see how in section view it has been looks. Yes, it is looks so good. Even in the keyhole, it is perfectly matching and the shafts are not intersecting to each other. Since we have a very good distance between 2 shafts, let me verify this distance. We have still 50 mm, so it is even more possible to move the shaft like another 10 or 15 mm likewise. I'm going to make it as 30 on both the sides. So now you can able to see the perfect match of the shaft and the keyhole has been presented here. So it will be very good connection. But in this way, in assembly, even whenever you are going to design the CAD model, you need to think in the manufacturing feasibility as well. In this way, as in the assembly feasibility as well. In this way, it is not very easy to attach the key in this keyhole. So I'm going to move this distance back to 20 mm itself, where I will have a gap here to insert the key, as well as in the opposite side shaft. So next part, I'm going to add a bush and the pin here. First, I'm going to add a bush. So to assemble, click on the assembly and select the bush. For the bush, I'm going to select this inner surface. Inner surface is a direct diametrical one, so not an issue. I'm going to have coincidence with this particular diameter. and also I'm going to have the distance this surface to be constrained with this edge surface in the coincidence. So here you can able to see the bush has been perfectly fitted inside the hole and along with the distance or the thickness of this particular flange. So in the same way I'm going to pattern this. Either you can assemble the rest of the bushes once again for all three positions. In case if you are going to reassemble for 8 positions or 16 positions means, then it would be take a huge time. So just to avoid that kind of repeated operations, we are going to use the pattern command for this bush as well. Selecting this part, click on the pattern and select the axis. Same way you can select this axis on it. By default it will take 4 conditions on 90-degree interval. So you can see the bush has been constrained and 4 holes in perfect match. So the constraint of all the 4 bushes also will be follows as same how we have constrained for the first bush. So in the same way, next I'm going to add it to a pin. For the pin I'm going to click on this particular surface will be constrained with this internal bush, and also the surface of this particular pin will be constrained with this flange, will be as a coincidence. So the pin is also got assembled, and here we can able to see the extended length of the pin has been assembled here. So in same way I'm going to repeat the pattern operation for this pin to get it on the all 4 directions. References, axis, selecting this and click OK. So pin has been assembled on all 4 directions. So in the last part I'm going to assemble is in the key. Select the key. Key is just a normal rectangular profile. You can directly select this surface to this surface, will be in the coincidence. And this particular surface will be connected to the shaft of the surface. It will also will be in a coincidence. The rest one of the surfaces in the vertical direction, selecting this and select this and make it as coincidence. So here you can able to see the key has been perfectly matching with the keyhole available in the shaft as well as the flange. So I'm going to repeat the same for the opposite direction. I'll just select this key, the surface will be on this particular surface, will be in the condition of coincidence. Just rotate in this way. The side surface of this will be constrained with this side surface. This is also will be in the coincidence, and the only depending degree of freedom is in this transfer movement. Select this surface and click on this surface. So this also will be considered as coincidence. Okay, I would like to change this surface to this one. Yeah, so this opposite direction which is on the male flange also, the key has been perfectly inserted in the flange. Now once again I'm going to click on the sectional view where we are going to see whether the part is perfectly matching or not. So here we can able to find one small issue. The issue is the keyhole which is in the flange length is very minimal. So we are required to have a flange length keyhole length in this flange to be until this end. I'm going to measure the distance, like from this area to this area is 17.5 mm. So I'm going to increase the keyhole length to 17.5 mm extra plus 17.5, which is equals to 30 mm. So now we can able to see the keyhole has been perfectly matched, and the same way I'm going to repeat it for the female flange. The distance will be like 30. So this is the construction of bushed pin flange coupling. The only part remaining in this is the nuts which we are going to assemble for the another end of these bolts or the pins. So in Creo we have a technique where we can able to get the standard nut and bolts washers along with the aligned pins by default. To showcase that, you need to go to tools command, and here we will have a option for screws. Just click on this, click on assembly on references. So I just wanted to assemble on this particular surface. The screw head starts here and screw thread ends here. So by selecting these two surfaces as references, you will get the all the standard list of the nut and bolts which is available in the Creo. I'm going to add a side to washer, and this value will be as a M20. Oh, M20 is a very big one. Here the diameter of this is considered as a 9, so I'm going to consider M10 bolt here, which will be perfectly fit, or else even M8 will be a good one. And I'll just click OK. By just clicking OK, you can able to see, and bolt is also created here, but that is not required for us. You can directly delete this particular component from this. So here you can able to see there is a washer and the nut which is perfectly matching with the pin which we have created. So the same way we are going to repeat this in the pattern command in axis way for all 4 directions. So all 4 directions you can able to see the washer and the nuts has been assembled. So this is the way where we are going to create the assembly view structure of the bushed pin flange coupling. I hope you guys have a clear idea on how to create an assembly for bushed pin flange coupling. Next we are going to create an assembly where we are going to demonstrate the animation of bushed pin flange coupling, how it will be activate, or how it will be working. So to create that, once again I'm going to create a new assembly file, and I'm going to rename as bushed pin flange animation. Just click enter. So a new assembly file has been created. So as I mentioned in the previous video, the same way we are going to use assembly constraints here. I'm selecting the male flange. Instead of selecting the default, I would like to select as a pin connection for this. So click on the pin. Here enable all the items. Now I'm going to give assign axis alignment. The axis alignment will be like this axis to this axis. Before that we need to create one axis, since we have not created it. I'd like to add an axis in all 3 directions. Now we can use these axes to the alignment of components. I'm switching to pin connection. I'm going to select this axis to this axis, and I'm going to select the plane to be as a coincidence. So here we can able to constrain only these 2 translations where this rotation will be left out to free. So we can able to make the animations in this. So the next one is I'm going to assemble a female flange. The female flange also will be considered in the same way. Before that, I would like to hide all these items which is not required for us. As of now, we are going to reassemble all other components just in the same way of how we have assembled the male flange to this assembly constraint. Now we are going to assemble remaining parts from the remaining parts to this male flange. So click on assemble, select the female flange, move to pin connection, select the axis alignment to the axis which is already available in the male flange, and the surface constraint is like I'm going to select this whole surface to this whole surface. It is not selecting here, so I'd like to select this surface to the surface. It is got connected. Yeah, let me align with this just for a few minutes. I'll make a small alignment in this, but later when we are assembling the pin, it will be get auto aligned easily. So next I'm going to add a bush. You can use it as a normal constraint, since it is not going to have a separate degree of freedom. But even though I'm going to use a pin connection, I'll select this axis to this male flange axis, and the surface from this to this male surface. And same way I'm going to repeat this in a pattern command in the axis bay, selecting this axis in all 4 directions. So the bushes are done. Next I'm going to create a pin, selecting this pin is also I'm going to give in a pin connection itself, selecting the axis alignment to this male flange axis, or else to this bush flange axis, so it will be very easy to align with that. And also the surface from pin to bush, it is again assembled, and I'm repeating it in the same pattern way. Click on the pattern, click on the axis, selecting this male flange axis, so it will be repeats on all 4 conditions. So the next is I'm going to assemble the shaft. Shaft is also the main component which is going to have a primary function on the rotation, so definitely we should give only pin connection for this. I'm selecting this one and the male flange as well as the surface to this surface in a distance way, and the distance would be like at 30 mm. So to assemble the shaft, I'm going to give a connection on the keyhole side. So I'm going to select the surface where the keyhole is present. So this is the surface where the keyhole is present. This side is the surface. Here I'm going to select this particular surface, and also I'm going to click on the surface in the flange. This is in the value of 30, so that I will have a keyhole. Where is the keyhole? Let me disassemble all these things. Keyhole is inside. So let me try to pull out the shaft a little bit. So I'll make it as 15. So I will have half of the keyhole outside and half of the keyhole inside. Next I will add another shaft in the opposite direction. Click on this, select the shaft, select this surface to surface, and this I need to be constrained as the pin connection. For the pin connection also in axis alignment, I'm like to select this surface to surface, and the pin, for the translation I like to surface to surface with the distance of 15 mm in the opposite side. So the shafts has been also assembled. Next we are going to assemble the key. For key I would like to select. For key you can able to directly give connection to the surface to surfaces. So coincidence. Next, sorry. Next constraint in this way to the surface in coincidence, and the third connection from here to here will be as a coincidence. So the key for one side has been connected. For the another direction also I'm going to give in the same way. I selected the key, the surface to be the surface in a coincidence value. So keys has been assembled in the keyhole on both the sides. The final part is going to assemble the washers and the nuts. For the washers and the nuts also I'm going to use washers as this one. This also will be considering as a pin connection from here to here, and the translation moment as surface to the surface will be in the distance. as a 9 mm. So one washer has been assembled. It will be patterned on all 4 directions as same as in the axis pattern. I like to select this axis line, and washers has been reassembled in the all 4 connections. Next we are going to assemble the nut. Yeah, this is the nut CAD model. For nut also I'm going to select a pin connection, select this surface, select this pin, and for translation select the surface and select this surface to be as a coincidence. And this nut will be patterned in all 4 directions. Axis, and click OK. So here we can able to see all the parts has been assembled: male flange, female flange, bushes, pins, shaft on the left hand side, shaft on the right hand side, key for the right hand side and key for the left hand side, as well as washers and nuts. Now we are going to have a mechanical simulation on this bush pin flange coupling and to showcase how it is going to be work. For this I'm going to click on the applications. Here going to click on the mechanism. In mechanism, we need to add the servo motor. To add a servo motor, click on that and select the main male flange, and in this switch to profile details, switch the driven quantity from angular position to angular velocity. The velocity of this should be like 20 degree per seconds or 25 as how you want. You can make these values and click OK. Now you can go for mechanical analysis. I would like to have this 3D connection in such a way. I'm going to click on mechanical analysis. In time I'm going to click on 100 and run. So here we can able to see a mechanical bushed pin flange coupling is rotating. As it is rotating, since we have connected the shaft along with the flange with the help of a key, the power and the torque will be transmitted from the left hand side shaft or to the right hand side shaft, or from to right hand side shaft to left hand side shaft, which is the shaft which is going to give the power is called as a driving shaft, and the shaft which is going to take the power is called as a driven shaft. Either it could be a power or it could be a torque. So this is the mechanical simulation of the bushed pin flange coupling where we can able to execute in the mechanical analysis. So just for the clarification, I would like to run it once again. So here you can able to see even along with the pins, bushes and the washers and the nuts, everything is rotating along with it, keyhole and the keys, shafts, everything. So this is the process how the bushed pin flange coupling will be applicable in the applications to transfer the torque from one shaft to another shaft. So I hope you guys it is well clear how to create a bush to pin flange coupling parts from the scratch to all the components, and how to create a rigid assemblies as well as how to create a flexible assemblies where we can able to simulate the operations like this. So I would like to close this video in this section, and if you have any doubts you can post it in the comments. In next video I will come up with the next any other mechanical components and the linkages, so it will be very interesting to learn and to try a lot. So thank you guys for watching this video, and if you like this video, give your comments and also share it with your friends, so it will be very helpful to share the knowledge from one person to another person where we are going to learn a lot. So thank you guys once again.